can't think of anything else. Periodically, you'll see that I post something in the chat to put your name and track number. I'm just trying to make sure that we get everyone accounted for. So thank you so much. I'll turn it back over to Paul.
All right, thank you, Brenda. Okay, without any further delay here, I'm going to go ahead and turn it over to Derrick. He's got his PowerPoint ready to go. And if you got questions, I guess you can put those in the chat box for us too, or there's a place down where you can have a reaction where you can, down at the bottom where you can raise your hand and we can get a question from you. So we've got about 18 people on, so it's impossible to let everybody talk at one time. So please keep your mics muted on your end. And if you have a question or something, raise your hand and I'll monitor that and I'll get with Derrick and see if we can't get you answers. So, all right.
Yep, sounds good.
We're on, buddy.
All right. So this doesn't really have anything to do with SOP. It's just my preference. I was taught this years ago. I'll always try to have some type of reference when you note something deficient in a report, whether it's the NEC, the IRC, a manufacturer. And I know on occasion you come across something that doesn't need a reference. And I'm not necessarily saying put that reference in the report, but I'm saying if somebody questions it, have something that you can go back to a third party, the NEC, the IRC, manufacturer, anybody that says, hey, this is why I put this in the report and this is why I'm saying this, not because Derrick said so in a PowerPoint presentation. So try to have something solid that you can go back to. Here is my information if you want it. I'm on Facebook, TikTok, Instagram. The best way to get a hold of me is either text or email or a message through Messenger through Facebook. So if I can help any of y'all at any point, I get calls and text all the time, and I do not mind that at all. So give me a call or chat or whatever if y'all need something. All right, clearances. You've always got to have specific minimum clearances to cabinets and panel boards, breaker boxes, whatever you want to call them. Minimum of 36 inches. And a lot of times it's not the electrician's fault. Oh, that's in the wrong place. But here we go. This is, so you've got foliage here that's blocking it. That image on the far left is out of, I believe it's out of InterNACHI. It's either InterNACHI or the ICC. The ICC has some wonderful graphics, wonderful images. So if you can go, if you can get on ICC and look at their images, they don't mind if you take them and use them. And they have a lot of great images, not only for electrical, but for everything. And I use a ton of those in my reports. Foliage that's trimmed. This one in the middle with the meter box, obviously the fence guys didn't care that they were doing that. And then the one on the far right, I obviously got to that because the cover's sitting there. I took the panel off and inspected it. So, and that's not really an NEC violation. I guess it is in a sense because you need to keep clear access to that panel, but homeowners either don't know or don't care a lot of times. So,
in this garage.
Oh, at the video, actually.
Locked by a bunch of personal belongings. I've been able to get the cover off, but clear access should be provided. There's several issues in the panel. This is a 2004 construction. We've got the conduit that doesn't extend into the panel, so the bushing isn't connected by current standards. That should have a bonded bushing.
Any standard.
Got a knockout here. It's missing protection on the wire. Two more up here the same way. These were probably added after construction. The wiring going through this one large piece of conduit should go through these smaller knockouts. The bond screw was not installed, so the neutral and ground bus bars are not bonded to the panel. We've got a white wire here here and down here that should be re-identified. Being that it's 2004, you should have arc fault breakers for the bedroom circuits. There's two of them. I'll have to check the labeling on it. But there you are. And by current standards, these lugs up here should have barriers on them to prevent accidental contact.
I had forgotten that was a video, so. But here's some more. That one on the right, I was kind of scared to go in there for that one. That was out in Hempstead in the country. I was a bit nervous going in there, but I got in there and got it inspected and out of there. So foliage is a big thing, especially up in if any of y'all inspect up in Wood Forest where they have the pedestals, and they always put bushes right in front of the pedestal, and you got to climb through the bushes to get to the pedestal. But that foliage needs to be trimmed or removed. Water softeners. Those guys apparently don't know that you can't block access to a panel. That's pretty common, as well as pull equipment. I always see pull equipment in front of these panels as well. I'm going to go back a couple of slides right quick. I threw these in here. I didn't have these slides in here when I built this presentation last year, but this is something new that's in 2023, and I thought I'd put it in a different place, but they're here. So the GFCIs, or receptacles on an island, they have changed that requirement or allowance, if you will. Receptacles cannot be placed on the side of an island or a peninsula any longer. So the image on the right gives you your three options. The first option is if you have a little pony wall with a backsplash, you can put the receptacles in there. The middle one is a pop-up receptacle, which is going to be quite a bit more expensive than putting a receptacle on the side of an island. For one, the device itself is much more expensive, and cutting into granite or any of these man-made countertops is not going to be cheap. The third option is the junction box down in the cabinet here. The code says that provision shall be made for future use or something to that extent. It's very vague. In my mind, that means they need to run 12-2 with ground to that junction box. And the reason I say 12-2 with ground is because it's going to be a 20 amp circuit. It's required to be 20 amps. But I guess in a sense, you could allow just conduit to be ran out there. But in my mind, there needs to be wire. That's the way I interpret that code. And you can take it upon yourself in new construction if you want to check that junction box to see if there is wiring in there or is not wiring. If it's hot, that is, in my opinion, beyond the SOP. So that's something that you can decide if you want to do or not. And then this just talks about it a little bit more. You're no longer required to have a receptacle on an island. That's why they have that third option of that junction box in the cabinet. And there it is. It only has to have provisions for future addition of receptacle outlets. And y'all are probably seeing the same thing. Every buyer is complaining about it. Builders are getting flack about it because people want electricity on their islands. And what I see happening is extension cords are going to be draped across or ran across the floor. And I don't see that it's going to help out the situation. So anyway, we'll move on a little bit. All right, and this presentation has mostly to do with panels. So the SOP says report the absence of a main disconnect means. It can be a single main. It can still be the 6 breaker throws like a split bus panel like we saw back in the 70s and maybe 80s. Now they can't install that anymore, but that is still an acceptable means of disconnect if it was original to the house. New for 2020, you must have a main disconnect on the exterior. And it must have some type of label on the panel to note that it's an emergency disconnect. So here's some examples of them. There's one brand or one printer or whoever that I found down in the South Houston area. They were printing them on some type of paper that was fading. So after about 6 months, it was just a white sticker on the panel. But one thing that did change between 2020 and 2023 regarding this label is they changed the wording just a bit that says the label has to be on the exterior of the panel, has to be visible without opening the panel. What I was seeing quite often was it was on the dead front cover on the inside of the panel. But they have changed the wording where it is required to be on the exterior where you can see it just by walking up before you open the panel, which makes more sense to me because it makes no sense to have it on the inside, but apparently they didn't think that through in the original wording. Absence of trip ties on 240 volt overcurrent devices. So trip handles, so on the left here, the red box, that's a 240 volt circuit. Both of those handles must trip at the same time, just like that one on the right here. Y'all can see my cursor, correct?
Yes.
Okay, thanks. So just like this one should have the handle tie. So both of them will turn off at the same time. This one here in the right picture, that one's broken. Now these are not 240 volt circuits. And they're not multi-wire branch. So they don't require, which hopefully we'll get to the multi-wire branch in this presentation. But these don't require it because they're not 240 volts. That's 120, 120. They're both on the same leg. They're just feeding two different circuits off the same leg. So doesn't require it. But this top one here, you can see somebody broke it off. Double taps on the main lugs. Those lugs are likely not rated for that. And this was going to a surge protector, which those surge protectors, a lot of times they'll put these small wires on 50 amps or 40 amps. And that's per the manufacturer, but you can't go straight to the lugs like that. It has to be on a branch service breaker, branch feeder breaker. Double taps. That far right one, you've got two of them right here. This is the same photo right here. I've got the same photo on all three of these. So those breakers are not designed for double taps. If they are designed for double taps right here, it'll have two wires right next to each other. Two little images of wiring right next to each other. That means you can put two in. And a lot of times it'll show, or there's only a couple of them will allow it, but it'll show two wires and it'll say CU for copper, but it'll only show one for aluminum. So you can't double tap aluminum. I've never seen one that you can double tap aluminum. There may be one out there, but I have not seen it. So double taps, you need to write that up on the ungrounded wiring. Here's what I'm talking about. Two little wires for copper. So that means that breaker, you can put two wires on it if they are copper. Aluminum, you can put one. So if they're not labeled and you see double tap, it needs to be called out. HVAC breakers. This is always a hot topic. You've got minimum circuit amps, which will determine the wire size. And I've got some labels to show you. So you have an idea of what I'm talking about. And then max fuse or breaker size will determine the breaker size. And a lot of times, if you go in there, you'll see a 40 amp breaker with 10 gauge wire. 10 gauge wire is rated for 30 amps, but it can go on a 40 amp. So this one right here, you've got max fuse amps or max circuit breaker, 15 amps, which is pretty small. And then you've got, I don't know why that bottom label's like that. It's like my image got skewed. Minimum circuit amps of 10.3. So this one is 15 amps. You're going to use 14 gauge wire either way, whether you go off the breaker or the circuit amps. But this determines your wire size, and the 15 up here determines your breaker. I thought I had more in there than that. All right, and then where this code specifies that one equipment shall be in sight from, within sight from, or within sight of, and so forth, another equipment, the specified equipment is to be visible and not more than 50 feet distance from the other. That is a blurb from the NEC just to clarify what in sight means. And that is talking about, normally talking about the disconnect for the equipment. We're going to skip over that. That's just talking about the integrity and how clean panels are. Like I said, I've got a 5-hour class here, so some of this I'm going to skip over. Paint, definitely call that out. All right, this is something new for 2023. Lugs for main service wires and main panels and some sub panels require covers. So in the past, since 2017, we've had the requirement for covers. The top right, these black covers, that's on a backfed breaker. Bottom left, you got these clear covers. Bottom right, you have the black covers. These have been required on the main panels, the main lugs feeding the panel since 2017. The new requirement for 2023 requires it on main panels and sub panels. Here's some other designs. But this down here would be required. Now, they didn't put it on the mains coming in, but they got it on the ones going out. So these up here, the top, the bottom, that's a main panel. When you get to a sub panel, you got to have them on the lugs coming in. That's a 2023 code, and we can go back and I'll show you. I believe I got the code number in here. 408.3. 215.15 and 230.62C. So if y'all want those code numbers. And they move some of this stuff around sometimes. So if I had, that may be why one of them says 408 and the other one says 215. But I came across these the other day too. I thought this is a pedestal main panel. It's the ones that are in the ground and they're about 2.5, 3 foot tall. And it's been questioned for quite a while if barriers were required on these, because I mean, you would have to literally almost intentionally stick your finger in that hole to get zapped. And now they have come out with these, I don't know if they just came out with them or if they just started using them. But they do have barriers for these. So I was questioning whether that needed to be written up in those pedestals, but now that I've seen them, I know there are barriers for them. Then I will be noting the absence of barriers on these pedestals now. This is kind of an oddball thing. We've got a metal building here That panel's right here behind this desk on the right-hand side. And this is just a close-up panel. You notice there are no ground wires in that panel. No bare copper, no green wires, no ground at all. They were using the building as ground. So they tied into, they screwed in right here on the right. You can see the 3 screws there. They screwed into this part of the steel building, and they were using the building as ground. And that's the first time I had ever seen that, so I didn't know if it was legal or not, but after doing some research, it is specifically not permitted. The following shall not be used as equipment grounding conductors: structural metal frame of a building or structure. So in the rare chance you do come across that, the building cannot be ground. Cannot be a conductor. All right, backfed breakers. So a backfed breaker has to be secured. So you've got the one on the left, you've got the little screw here holding it in place. The one on the right, you've got the piece of plastic there holding it in place. And there are a few other designs. That's just 2 that I grabbed out of my photos. And the reason it has to be secured is, let's take this panel on the right-hand side. If I go in there and I pull this 30 amp breaker out, this second one, if I pull that 30 amp breaker out, that breaker is dead. I can touch the back of it, the front of it. I can touch that lug. Nothing will happen. It's dead. If I pull this one out, everything's still live. That is a live breaker you're holding in your hand. That is the reason that it needs to be secured to the panel. It's not going to jump out of there. This one, where the blue arrow is, there's a screw missing. So it's meant to have the screw in there, but there's no screw holding it in place. There's a close-up again of the plastic hold down. That's one of the more common 2, the plastic hold down and the screw. How about a backfed breaker from solar? Does it have to be secured? And after much discussion at the conference, it was determined that it does not, because the solar system has a protective device in it that will take care of that and won't require it. So if you can, I thought it was a backfed breaker, so yeah, it has to be secured, but it does not. You remember earlier when I said, hey, always try to have some type of reference? Here's a couple occasions where I don't think a reference is needed. If I call this out and an electrician calls me and says, what reference are you calling? I'm going to say, I don't need a reference for that. The one on the left, I mean, yeah, it's supposed to have a weatherhead, but if an electrician calls me about that, I don't need a reference. You got water intrusion. And then the one on the right, you've got a nail in there. And you've got so many wires and so many different size wires tied into that split nut that, yeah, it's an improper connection. And you could probably find a reference for it, but you don't need it. Ground rods and clamps. What we mostly see in the Houston area, or what I've mostly seen, are ground rods and concrete encased electrodes. And the way I understand it, the city of Houston requires a concrete encased electrode. I still note that it may be ineffective because there's plastic under the foundation, so you may not be getting good contact with earth. So I just note that. And then I also recommend a second ground rod unless an electrician can measure it and certify that there is 25 ohms or less of resistance. I do not measure it myself. I know there was an inspector in Austin that was doing it, but again, to me, that's way beyond the scope of an inspection. I note that it has one, if it is there, and recommend a second.
Hey, Derek, question about that.
Yep.
Is rebar approved for a ground conductor? Electrode?
There, not for a ground rod. Uh,
For the concrete?
there is- It says it has to be rust resistant or something to that effect.
Correct.
So in my opinion, no, that concrete encased electrode, that's just a piece of 20-foot rebar in there. That's raw steel and it's going to,
Gonna corrode and rust.
corrode. Yes. So no, in my opinion, no, it's not. And the other thing that they put in one of the last two code cycles was that apparently people used to do this. I don't know because I don't do that many metal buildings, but there was a way that they would weld a piece of rebar to the metal structure, go down to the concrete encased electrode. So they would actually tie the metal building to the concrete encased electrode with a piece of rebar, but that can't be done anymore. They specifically omitted that piece of rebar from being connected to the steel structure for some reason. I guess they're wanting it to go directly to the panel with a copper wire or something, but they changed that wording in either 17 or 20, but no, the rebar, in my opinion, it'll corrode and it's not gonna work. And then if there are multiple rods or plates or pipes, they need to be a minimum of 6 feet apart, which there are a few builders putting in 2 ground rods, but very rarely do I see it. Maybe 2 or 3 times a month. It's got to be within 8-foot contact of soil. There are exceptions where it can be driven at an angle. I don't think that exception's going to fly around the Houston area, but up in the hill country where there's rock, it can be. And there are certain provisions where it can be buried also. But do you always check them? I always pull on this wire, on that green wire or black wire, whatever's down there. I pull on it to make sure that it's connected, especially if that connection's below ground. But you can see that one, there's the rod there and there's the wire there and they're not connected. So that's absolutely a deficiency. The one on the right, I'm not exactly sure what's going on there. It may be that type of clamp. It may be loose. Here's these pedestals I was talking about that I've mentioned a few times. So the interesting things about these while we're on grounding, there's a little label inside of here, and I thought I had it, but I guess I don't. It may be further down in the presentation. There is a label inside of these that says you do not have, it doesn't say it in these same words, but you don't have to drive a ground rod out here. By burying this pedestal, it establishes ground. And there's a little white label inside the panel. I think it's right there behind that wire on the left, on the right picture, on the left side of the right picture. I think that's the label. But it specifically says that ground is established. Now, that being said, with this pedestal, you have to have a ground rod at the house because the code says a ground rod shall be provided when a sub panel is on a separate structure from the main. So pedestal, you have to have a ground rod at the house. And then if there was a detached garage, you would have to have a ground rod at the detached garage if there's a panel there. So anytime a panel is on a structure separate from the panel it's being fed from, there has to be a ground rod. And always double check those ground rods. That one was made out of gummy bears. All right, bonding of main conduit entrance. This was I think 2017, I'm not 100% sure, but it's been in the code for a few years. It may even go back further than that, but these bushings here, you need the grounded fitting whenever all knockouts are not removed. If all the knockouts are removed and this nut is on there, that nut provides the bond. But for instance, and I know this is on the meter, but just for reference, you see the concentric knockout that's left there? That, if it was going into the panel, if that concentric knockout was here, then this would be required. This is actually not even required in this panel because all the knockouts have been removed. So you got a double bond. You got a bond here through the wire and you got a bond at that nut right there. And also, they make these that are hinged. So if you get to a house and you call that out, you note it as a deficiency, and the homeowner says, or electrician says, well, I got to disconnect the electricity from the meter box. You don't have to do that. It's hinged right here. You cut the old plastic one off, or they cut the old plastic one off, and then it hinges around there and a screw tightens, and then it's bonded. So pretty easy retrofit. And I have seen a couple of those out there. They're not real common, but they are out there. All right, bonding equipment. A lot of people struggle with bonding and grounding, but it's really simple. It's either bonded and grounded or it isn't, and that's the end of it. So we're done with bonding and grounding. Just kidding. Intersystem bonding termination. This is way back from, I think, 2008 or 2011. They've been around quite a while. This is the example that I use in my reports quite often. So bottom one is the same as the top. The bottom one just doesn't have the cover on it. And the requirement is you have to have 4 lugs or capable of adding 4 bond wires for telephone, television, internet, whoever. And that's going to go on the normally where I see it's on the main ground, but I have seen it a couple of times here lately where they just ran an extra piece of ground wire out of the panel, a foot or so long, and stuck it on the wall kind of close to the panel, which is fine too because it's all bonded back to each other. This is one I found 3 or 4 months ago. It's an interesting design, but say a bunch of say telephone, television, and internet were all bonded here. Say you had three bond wires connected there, and in 10 years this thing breaks and falls off. The homeowner's not going to go find that. That's the problem I have with that. The homeowner's going to go find a pipe clamp and stick it back on there, and he's going to shove them all in there together, which is not the intent. So I'm assuming it's UL approved, but just my opinion, I don't like the design because when it breaks or wears out, it's not going to get replaced. It's going to get replaced with something else. It's just like when an arc fault breaker quits working, just a regular breaker gets thrown back in instead of the arc fault. This is still talking about the IBT. It shall be accessible, consist of a set of terminals with capacity connection. Oh, not less than 3 bonding conductors. All of them I've seen have had 4 though, so I guess they went above and beyond a little bit. Shall not interfere with other equipment. So you can't use the ones on the panels anymore, on the sides of the panels. And has to be at the main service or building, disconnect, and shall be secured to the structure or the GEC. So that one previously was secured to the GEC, and it shall be listed for such use. And then may not be required on existing buildings or structures. And what they're getting at there is if somebody comes in and does a panel replacement, they're not required to add that. So I'm not calling that out on a 1999 home, because more than likely bonding and grounding is going to get, it's already been established. And nobody's going to come out there if they're replacing the panel. They're not going to throw one of those on there and then go find all the other wiring that needs to go to it. They're not going to go find the internet. They're not going to go find telephone bond. They're not going to go find those bond wires that are supposed to be connected to there. So I don't see any reason to call it out on an older home. Neutrals doubled. Back in the back there. So this has been a requirement actually for practically forever, not specifically in the NEC, but panel manufacturers did not allow the neutrals to be doubled up. But the NEC now has added it, and I can't tell you what year it was added. But 40841, each grounded conductor shall terminate within the panel board in an individual terminal that is not also used for another conductor. So in other words, one wire, one screw on the neutrals. Same thing. All right, this right here. I'll try not to confuse y'all, but you see all the bundle of neutrals here? So is that allowed? Yes and no, because it depends. And I don't know why this picture's crooked all of a sudden, but it is. That panel was installed vertically, not horizontally. But this normally is not permitted unless every ungrounded circuit, so in other words, every black wire that's coming into this panel that's associated with every one of these wires, if they were all done like that, then that's fine because that is now one circuit. But all of these black wires are connected to individual circuits. So you've got 1, 2, 3, 4, probably 5 different neutrals in here. So if you disconnected this screw here, you just disconnected neutral on 5 circuits. Or if that wire nut comes loose, if it comes off, you got 5 open neutrals. So this can be done only if the corresponding hot wires are done the same exact way. And just a side note, the yellow and red, the colors indicate how many wires can go into a wire nut. And I don't know these things off the top of my head, but when it's 2 different colors, then there's 2 different variances that are allowed. So say the red allowed 5 and the yellow allowed 6, it can be used for either one, is what I'm getting at. So I hope that doesn't confuse y'all on what I'm saying about the neutrals there. All right, ground wires. They've got all these ground wires coming off these branch circuits up here, twisted together and under one lug. Not supposed to do that. It was pretty common to find back in the 70s or beyond. But most panel manufacturers allow 2 or 3 ground wires as long as they are the same size, the same gauge under a single lug, but never can you bundle 18 of them together and put them under that one single lug. Granted, you're probably getting a pretty good connection there and pretty good continuity through all of them, but technically it's wrong. We'll skip over that. Separation of grounds and neutrals in a sub panel. So this is where I see a lot of confusion, not only with inspectors, but obviously electricians, because I'm writing it up constantly, even on new construction. Greg Ginzer put a post out today about the same thing. There wasn't ground established between the main panel and the sub panel. So in a sense, it was only a 3-wire feed from a main to a sub. So we'll take a look at this panel. This is a main panel. And to me, they got a little carried away. They've got the bonding bushing down here with a ground, or a bond wire rather, going up to this ground bus bar. They've got a ground wire going across to this bus bar. They've got three different, I'm assuming bond wires disappearing. One of them went to the ground rod, one went to gas piping, and one may have gone to the main panel. But this is all redundant in this panel. If this was a sub panel, some of it may come into play, but this is redundant. You've got your main ground coming in from the panel right here. I mean, from the meter, sorry. This is your neutral from the service provider. And there's your bond screw. There are no branch circuits, so there are no grounds. There are no grounds anywhere. So, and this ties to here. So you've got your neutral going here. The only problem is they don't have ground. Ground has got to come from somewhere in here. It can't come from out here because now your ground from this panel to the sub panel is traveling through the panel. I hope everybody understands that. So if let's say that this top wire right here is the one going to the sub panel, and that's your ground between the panels. That's your 4-wire feed. You got your 2 hots, neutral, and ground. Everybody understands that you have to have a 4-wire feed to a sub panel. So this ground wire needs to originate here or over here because these are tied together back behind the panel. So they should have tied this into, say, right here and gone through. So, oops, didn't mean to go that fast. So essentially, you're using the panel as a conductor, and you cannot use a panel as a conductor. Now, on this one, they took it one step further. They tied these two together, and this, once again, is a main panel. They tied from here to here. They tied from here to here. So when they ran this wire from here to here and this wire from here to here, this bond screw became redundant because you're bonding all the bus bars together and you're bonding the panel to the neutrals and the grounds through these wires. So they got a little carried away, but there's no question that this panel's bonded and all the grounds and all the neutrals are bonded. Now, now keep in mind, this is a main panel still. If this wire was not here and this wire was not here, the panel would be connecting the 2 bus bars. Here's your ground wire coming from earth ground. And in this panel, since these are tied together with this wire, it does not matter where this connects. It connects here or here. If this wire is gone and this wire is gone, then this ground has to connect to the neutral. Because the fault, if this wire wasn't here, the fault would travel from the bus bar to the bond screw to here and down to earth. If this is connected here, it just goes straight to earth. So the bars have to be directly connected as they are, or the ground wires have to be on this bus bar, on the neutral bus. All right, here's another main panel. This one's actually done right. Now it's missing the lug covers up here. But here's the main ground going from the main panel to the sub. They came and grabbed this on the way, which is fine. It doesn't have to be a separate wire. They came in here and grabbed that and went to the sub panel. So this one is actually one that's correct, and it's got the bond. The bond screw, back up a little bit and talk about the bond screw. The bond screw bonds the panel. The bond screw is not intended to bond the neutral to the ground. The bond screw is intended to bond the panel. Wire size, we're going to skip over that. All right. Multi-wire branch circuits. So a multi-wire branch circuit is very similar to a 240 volt circuit, where you've got, let's take this 240 volt circuit right here, this 40 amps. You got 120 amps here and 120 amps here, and they're on opposite phases. So this one goes out, and then this one goes out, and that one goes out, then that one goes out. And then they return on, well, if it's balanced, nothing's going to come back on the neutral. Neutral's going to be 0. Now, come down and apply that same, or let's go to the right side of the panel. Let's apply the same thing to this set of breakers right here. You got 120 volts on this 20 amp breaker and 120 amp. Somebody tell me what an amp volt is. I'm losing it. You got 120 volts on this leg, 120 on this switch, but that single breaker is on only one phase, only one leg of that panel. So they're both going out at the same time. They're traveling parallel. These are traveling in series. That one goes, then this one goes. This one, they're both going at the same time. Boom, boom. And it's not going to hurt. You got 120 volts, or let's say we're pulling a lot, and we're pulling 15 amps on this one and 15 amps on this one, and they're both going out at the same time, traveling that one and that one, 15 amps. They're both going to get to that device and hit that neutral. Now they're both coming back at the same time on the neutral. So you've got 36 amps coming back on that neutral. That wire is rated for 20 amps, and and the neutral is rated for 20 amps. Let's say it's this one. You're pushing 36 amps back on that neutral now because they're both going out at the same time. This is something that I find 2 or 3 times a month. This one's rather excessive because there's so many. But these little tandem breakers are not intended for multi-wire branch circuits. This over here on the left, you've got the one up top and the one down the bottom. That'll work because they're on 2 separate phases. This one's going out and then this one's going out. And so your neutral will be fine because they'll be running in series. This one goes out and hits the neutral and it's coming back. And then this one goes out and hits the neutral and it's coming back. So they're traveling in series. You're fine. These over here are traveling at the same time. It's not going to work. It's like trying to put 2 tennis balls side by side into a tennis ball can. It won't work. So you have the potential to push over 40 amps onto that neutral, and then the neutral is going to fry. So these were a great idea to save room, but they are not intended for multi-wire branch circuits.
Hey, Derek, this is Rodney.
Yep. Yes, sir.
Can I go out on a limb and challenge the way you worded something?
Sure.
Those breakers right there, look at the one breaker with let's call it line B down there with the black wire and a red wire coming out of it. Okay.
Yeah.
Go up, right, go up one breaker. Well, whoa, now you're way up. No, down. You were down lower. Just grab any 2 breakers. Those 2. Stay on that one right there. Yeah, those 2 sets of breakers right there. If you could put a trip tie on that, then across both of those pairs, then it would be okay. Because take the lowest wire in that set of breakers, the red wire, okay?
Yeah.
The red wire. He's paired with, if they did their pairing correctly, he's obviously not paired with the black wire right next to it. They're coming out on the same leg. That bottom red wire is paired with the upper black wire.
It could be. It could be. So you're saying that this one may be paired with this one?
Most likely, yes.
It could be.
Yes.
It could
So,
be.
so if
But-
I write that up, I would write up that there's no taking those two breakers. I would say there's no trip ties on two sets of multi-wire branch circuits. And if those wires are paired correctly, which most likely they are, because they look like they're done neatly, then there would not be a problem with the reverse current flow.
Yes, I agree with you totally.
Okay.
And it is very possible, but again, I'm still gonna call it out and have an electrician check it because I'm not gonna trace all those circuits.
Yeah.
I mean, I
Frequently,
could-
they'll have the pairs of wires, black and red, twisted together, but still it takes
Yep.
a while to trace them out.
Right, right. No, I
Okay,
understand
I'm
what
done.
you're
I
saying.
just wanted to point out that it, myself, less knowledgeable than you, of course, myself, I would not say those breakers are not designed for multi-wire branch circuits. I would say as long as they make the proper trip ties for the inner two pair and the outer two pair, just like a 240 volt breaker, as long
Yeah,
as they make the proper trip ties, then
yeah, but I don't know that they ever designed a trip tie for these style of breakers though. I know they make the ones that have the little silver clip here and then or the silver clip that goes on the outside and then the plastic here, but I don't know if they actually made them for these tandems. They may have, but
Yeah.
I haven't.
if you go to the left one breaker on the other side of the panel, they've got the inner pair, obviously with a trip tie
Right.
on it. But
Yep,
in that case,
He's
nothing
on.
on the outsides.
right. Yep. No, I
Okay,
agree with you totally.
Okay,
And I don't word it that it is wrong. I word it that there's a potential to overload the neutral, that it needs to be investigated.
now in some
So-
cases, you'll see where there's obviously, uh, say 4 red wires, lined up together, and then 4 black wires, and like a 4
Yes.
wire bunch of reds and a 4 wire bunch of blacks. Those are
Yep.
obviously wrong.
Right.
Okay, I'm done. Thank you.
All right, good comment, thanks. Here's another one. And this one, it was the only one in the panel, so I'm pretty certain that it's wrong. Because you've got red and black. But again, I try to stay away from absolutes, and hopefully y'all do too. Appears to be, and have it further evaluated. That's not one of y'all texting me, is it? Nope. All right. Let's see here. Here's one done correctly. It's hard to see, but you got a black wire and a red wire with a trip tie. So that multi-wire branch circuit was done correctly. But that's what it should look like. Got somebody calling me. Sorry, guys. Let's see here. Here's another one. This one, all it needs is a trip tie because it's on 2 separate legs. You can look at that 30 amp breaker over here. You see 240 here. You got 120 here and 120 here on opposite phases. So all that needs is a handle tie. So that's a pretty simple one. Here's one that was interesting. You can see we're on this right here. This one phase is feeding both sides of this, 30 amps. That's for an electric dryer. Not going to work because when you go across the bottom one to ground, you get 120. You go across the top on the ground, you get 120. When you go across both of them together, you're sitting at 0 because they're on the same phase. I always check the dryer receptacles with this multimeter. If there's not a dryer there, I always check it, and I was getting 0 across it, and I was getting 120 to ground on both of them. So I went back to the panel and checked that a little bit closer, and that's what we found, 0 across it because they're on the same leg. We're gonna skip that one. Surge protection. This was added in either 2017 or 2020. I think 2020, they added surge protection, a requirement for SPD. It can be in the main panel or it can be in a sub panel. That's what all this says. And it's the exact same wording. That's from the National Electric Code. That's from the IRC, and they both say the exact same thing. So just make sure they're there. This one is a square D, and I believe it's the square D is the only one that is required to be closest to the service entrance wires as possible, but you have to dig deep in the installation manual to find that. This one, obviously, installation manual doesn't say it has to be right next to the or closest to the service entrance wires, because this panel is designed to have it put right there and then goes into the breaker here. So you should be looking for those. I don't call that out again. I don't call that out on a 2000 home or 2010 because it's a relatively new requirement. They may add that to the SOPs at some point, but as of yet, it's not. White wires used as hot, they have to be re-identified. The two on the left here, a marker, tape, some type of identification to note that they are used as ungrounded. I'm gonna skip this video, but if y'all want to look at it, it's talking about dishwasher and disposer, if it has to have one breaker for each, or if they can share a breaker. But this video is on Facebook. If you go back and search my name and then look for a dishwasher, just keyword, you can find this video. It's about an 8-minute video, and the guy goes through about 7 or 8 different codes in the NEC to determine this, and it all goes back to load calculation, which is way beyond our scope of inspection. But in general, if it's a 20 amp circuit, they can both be on the same circuit. If it's 15, then they both need their own breaker. But like I said, go watch the video. It's on Facebook on the Tapria page. Bathroom lights and receptacles. Bathroom lights can be on the same circuit as the receptacles as long as that circuit does not leave that bathroom. If the receptacles from more than one bathroom are on that circuit, then the lights cannot be on that same circuit. And that's, do you look at breakers for the bathrooms? So make sure 20 amps, and here's the exception where the lights can be on the receptacle circuit. So if it serves a single bathroom, then lights and receptacles can be on that same circuit. If it's more than one bathroom, the lights cannot be with the receptacles. That's the same thing I just said. Freestanding generator lockouts. I see more times than not that the freestanding generators are not done right. Saw one today. I still can't figure out what he was doing. I think there was a switch that he would turn off to hook the generator up, but I'm still not 100% sure. It baffled me. But these lockouts are supposed to be on there for a generator, for a standalone. This is not a whole house generator. Whole house generator, I disclaim that generator and the generator panel. But you should see something like one of these two photos if you see a a plug for a generator. I'm gonna skip that. I call this out on new construction. But you can see on the left-hand photo where that meter box is pulled down about 1/4 to a 1/2 inch. You look at the ground down there, the ground is drying and pulling away, so it's pulling the meter box. And a lot of times you'll see it separate right here at the bottom of the meter box at that conduit. And I've even seen it pull the knockouts out of a meter box. So I note that there are exceptions to that. It depends on what they've done underground. If they've allowed for excess wire for movement, then this is not required, but I can't see underground, so I'm calling it out. Overhead, proper clearances and connections. You've got a chain right here holding it in place, which is not permitted. Looks very low as well, depending on where you're at, over what you're going over, 10, 12 feet above grade. You need what, 18 inches of clearance between the roof and the, somebody help me out. What's that called? Service loop, the drip loop. You got to have clearances there. And then if it goes way over the roof, then you've got to have clearances here, but this one's pretty much to the edge. So that wouldn't be considered here, but always check those. Here's one laying across a roof. Definitely wrong. And then you got a pretty good potential for water intrusion here. So several issues there. I would note stuff in the roofing section and electrical section for this. I found one like this on a metal roof one day, and I told the client that I was not going to put my ladder against the roof. I was looking at the roof from the ground, and I was not going on the roof, wasn't touching the roof, wasn't doing anything with the roof until they got that corrected. So I always look at that, especially on metal roofs, before you get up there. 230.24, that tells you the clearance is above everything. And there is there's a pretty good graphic that I think Code Check has with all those in one graphic. All right. Are we planning on taking a break? I don't need one. I'm just asking.
No, not necessarily, Derek. You can keep going if you don't need one.
Okay. And here's all the clearances again, 230.24. I'm not going to go over each one specifically, but that's where you can find them. And I have a folder of photos on my phone that I have all kind of stuff like this in. I have a photo of glass, or not a photo, an image from the ICC for requirements for tempered glass next to a door. I have the image for the clearances. I probably have close to 150 images in there just for things like that I've collected over the years. So it's just a nice place to go back and look where they're all in the same place. I can add them to the reports real easy if I need to. So if y'all see stuff like that, I would encourage you to grab those photos and keep them, or images rather. I keep calling them photos, but they're images. Aluminum versus tin copper. Aluminum typically will look more like Romex. It'll have the plastic sheathing. Where the tin copper from way back in the day, from like the 50s, will have the more of a rubbery or a cloth cover. And also aluminum will generally correspond with the Vietnam War era, from the late sixties to the early seventies. And the story supposedly is that the military needed the copper for the war effort. And so the electricians had to find something else, so they went with aluminum. So if you are finding aluminum, I don't see much tinned copper. Because the area that I'm in, I don't inspect too many houses of that age. And a lot of them that had tinned copper have been remodeled and rewired. So it's somewhat being phased out. But if you do find aluminum, you need to check the devices, the switches, the receptacles, to make sure that they are compatible with aluminum, or some type of pigtail that is approved has been added. I will generally go check one device in each room after I've determined there is aluminum. And note that after a random sampling, either the ones that were sampled and inspected were updated in an approved manner or were not. And I believe that's the only place in our SOP where it allows for random sampling. There was a discussion about random sampling of receptacles in general. The way I understand and read the SOPs is if that receptacle is accessible, then it needs to be inspected and tested. You need to plug your tester in and make sure it's wired correctly. It's hot, it's not reverse polarity, it has ground, it's GFCI protected if required, and so on and so forth. But with the aluminum, the way I read the SOP is you can do a random sampling. You can have devices that have the labeling of Kolar on them, which is copper aluminum revised. If it says, the first one came out, said CUAL, that was copper aluminum. And they didn't work. So they came out with CO/ALR, which is copper aluminum revised. And those are the ones that are still approved by today's standards. The pigtails you can put on, they have what's called a coupulum crimp, and I've only seen that one time. That was a special tool that you had to use. There are wire nuts that are designed and intended for aluminum to copper, which are going to be purple. They designated purple for that specific application, and it has the antioxidant already in it. And just recently, in the last few years, they came out with a device that has several little lugs and screws in it. And I've seen that one time, and it is UL listed and approved for copper to aluminum connections. It looks similar to a Wagyu or Wago. I think it's called a Wago or a Wagyu, one of the two. But instead of just plugging in, it has set screws to tighten down on it. Copper clad aluminum versus copper. So here recently in the last couple of years, I've been seeing copper clad aluminum. DR Horton is using it quite a bit. I know there's a neighborhood up in Willis that is exclusively copper clad. And also over in the Humble area, there's another one. But every DR Horton home I've been in here lately has had copper clad aluminum. And that has to be treated like aluminum wiring in the sense of sizing. So 20 amp circuit has to have 10 gauge wire. 15 amp has to have 12 gauge wire. The problem I ran into is that the receptacles were stamped on the back and labeled that said 14 gauge or 12 gauge wire only. So you couldn't use it in a 20 amp circuit because a 20 amp circuit requires 10 gauge wire if it's copper clad aluminum. So I did some digging. Actually, a client of mine did some digging because I wrote it up, and he dug and dug and dug, and he found on Schneider's website, which is the parent company of Square D, that says even though their devices state on the back and are labeled for 12 or 14 gauge wire, that the 10 gauge wire for copper clad aluminum is permitted to be connected to their devices. And it's also on their website after it's their website, and they also emailed him a letter. So there's two sources. So what I am doing now, if I come across copper clad, I simply note that it was not determined if the devices were compatible with copper clad aluminum and leave it at that. Kind
Hey,
of a
Derek,
CYA. Yeah,
you may have said this already, but how do you spot the copper-clad aluminum wire? How do
you
you
got to, if you
differentiate it from
lick it,
copper?
if you lick it, it tastes different.
Yeah, okay.
Well, one
Once.
thing you're going to open that panel up, and hopefully you're going to see 10 gauge wire going to 20 amp breakers. So that should be an indication.
Okay.
And it's going to be orange, just like normally it's going to be orange. I did see one day where they had purple sheathing on 14 gauge wire, which that's what got me to looking at it. I was, what is this purple wire? And, but normally if they've done it right, you're going to see 10 gauge wire going to all the 20 amp circuits, and you're going to see 12 gauge wire. You're not going to see any 14 gauge wire. So that's one indication. And then if you can see the end of the wire, it's silver. It'll be copper on the outer edge and silver in the center. And then also you can, if there's any sheathing available, it says copper clad aluminum on it. It's printed on there in black ink. What I've seen is, and yet, so, you could go up into the attic and verify it maybe, if you can't verify it in the garage, in the panel, I mean. But, yeah, the first indication is a lot of 10 gauge wire. So
Okay. Thank you.
the other thing I'm seeing, DR Horton do is every circuit, every 120 volt circuit has a combination arc fault and ground fault breaker. Everything, lights, receptacles, bedrooms, doesn't matter. Bedrooms are arc fault and ground fault. Every circuit's got both. I don't know why they're doing that. Maybe it's just easier, but definitely, I mean, it's not costing them that much more. They're even putting it on the furnace. The 20 amp breaker for the furnace, they're putting a combination arc fault and ground fault. So, Bulldog panels. Has anybody ever seen a Bulldog panel? I saw one about 18 years ago, and it was dead. It wasn't being used. It was in a barn. But then about 4 or 5 months ago, I came across 3 of them in one house. So, these are push button breakers. They don't flip side to side or up and down. It's a push button. And, they're outdated. Um, I don't know that you can get a breaker for it if a breaker went out. I would doubt that you could. I mean, with eBay and everything, yeah, you could probably find one, but I don't think they manufacture breakers for them anymore. So, a Bulldog panel, if you come across it, I would recommend it be replaced. One, because it's going to be old and outdated. And I would be willing to bet that at least some of the breakers are not going to trip when they're intended to. Zensco panels, sometimes they're called Sylvania. Be careful calling out Sylvania panels. Zensco panels, I recommend replacement because there has been documented cases of issues with them. And then some Sylvania panels, because Sylvania bought Zensco and kept the design around for a while. So some of the Zensco panels will say Sylvania. Now this one I have an example says Zensco Electrical, and it also says Sylvania. You'll come across some that just say Sylvania, that are designed just like that. So if you're not familiar with Zensco panels, I would encourage you to study up on them so you could recognize them. So if it doesn't say, if it says Sylvania, you can say, oh, that's a Zensco. Because there are Sylvania panels out there that look like a Siemens or a Bryant or any other common ones that were built back in the same era. So make sure you can tell the difference between them. Up into the 70s, the Zensco made them. The bus bars corroded easily. Some of the components of aluminum needed to be replaced after 30 years. Breakers melt into the bus bars. And then some of the panels may continue to conduct electricity even when the breaker appears to be off. So this is just some information I pulled off the internet one day, just being curious about them. So if, and I know to replace Zensco Bulldog, which obviously aren't too common around here. And then also Federal Pacific. And I never get any flack back from anybody. If I recommend replacement, I never hear back. I explain to them why, and they ask how much, and I say, you know, get an electrician out here to get a firm bid, but you're looking at a couple of $1,000s, and I never hear back. So it's I think it's taken quite seriously, or received quite seriously. Federal Pacific panels, same thing. There's been issues with them. And there's different variations of Federal. There's Federal NOARC, there's Federal Pacific, there's another Federal out there. I can't think of what it is. But if I see the word Federal and those red breakers, I'm recommending replacement. I've been in some of these where you can hear them humming. You can hear a little buzz from the main breakers. So obviously there's issues with them. And if you go on to there's a government website there where they did the study twice and they came up with the same results twice because they did it. And then there was a few years later, there was some questioning of if the testing was done correctly. So they redid the testing. They came up with the same results. Consumer Protection Agency, I think, is who did it. But there's plenty of information out there on Federal Pacific, Federal NOARC, Zensco, Sylvania, Bulldog. If you recommend replacement, like I said earlier, always have somewhere to go back to, always have a reference to go back to. There's plenty of information to go back and reference if there's a buyer or seller that's questioning why you're recommending replacement. FPE 50s through 1990, which I didn't realize they kept them that long. I thought it was the early 80s, but this information I found said up to 1990. So they were never recalled. So don't use the word, don't put in your reports, hey, they were recalled. The company was gone. They couldn't be recalled. The company was gone. There has to be a company to recall them. But make sure that you recommend replacement, but don't put in your, there it is. Consumer Product Safety Commission is the one that investigated them. And like I said, they did it twice and came up with the same results twice. So they said, all right, we need to get this information out there. But yeah, don't use the word recalled because they weren't recalled. The company went out of business. Same way with Zensco. No indication that they were ever recalled. So just kind of, it's one of my pet peeves of using the correct verbiage in reports. Like receptacle and plug. I can't stand to see the word plug in a report when you're talking about a receptacle because it's not a plug, it's a receptacle. Or outlet. Use receptacle. It is an outlet, but let's be specific. So that's just one of my pet peeves. So I'll get off my soapbox. Challenger panels. I have heard some inspectors say that they recommend replacement on Challenger panels. The only information I can find is that there were some recalls on a few breakers in 1988. The panels themselves, as far as I can tell, were never recalled. The panels were not the issue. There was about a 3 or 4 month span of breaker manufacturing that was incorrect. And so there was an issue. So I know there are parts of the country where I see on Facebook that says, some insurance companies won't insure your house if you have a Challenger panel. I know of nothing of that. I know nothing about that here. So, just be careful if you're calling out Challenger panels to be replaced because it may not be, a requirement or a good recommendation. So, um, anything jump out at you? And, there's the main ground wire right there. That was coming in from the, main to the sub. There's your main ground. It's just hanging out in La La Land. Was never connected to, bus bar. Never connected to the ground. So there was no path for ground back to the main panel. All right. Are the breakers compatible? You see how all these breakers are kicked up at an angle? And you can see on the right with the dead front cover, see the big gap? Those breakers are not seating down in that panel correctly. Because this is a Siemens panel and these are square D breakers. Everything was hot. Everything was working. All the circuits were good. Everything was grounded, polarity. But you don't have good connection there. You don't have proper connection. The manufacturers don't allow that. I mean, warranty's gone. It's probably gone anyway. Looking at that dead front cover, it's been around a while, but I don't get too carried away with unmatched breakers, but because there's so many different ones, if it's BR, it can fit in here. It can fit in there, but this was very obvious. So definitely I wanted to call that out. All right. I want to talk about, I want to go back. There was something I was wanting to talk about and I don't remember what it was. Are there any questions that y'all have on the chat, Paul?
No, just some comments is all, not really any chats on it. Can you hear me, Derek?
Yes, sir. Yep. I was just looking at I just pulled up the chat.
Yeah, just take a peek at that and see if there's anything you haven't answered. I've been watching it, but I think you pretty well answered most of them as we go along.
Okay. Yeah, here's that Jim Heim said, insurance companies might not insure homes with certain panels. And I haven't come across that specifically, but I have heard that, I've heard that, said a few times over the years. So, definitely. Um, I just read Clay's comment. Sorry, that's why I'm laughing. What do you call out when the IBT is on one side of the house with the panel, but the low voltage phone cable, et cetera, on the other side of the house? I don't know who that is. Oh, it's Clay. I don't say anything because because it specifically says in our SOPs that um, we're not required to inspect low voltage systems. And that IBT is designed for low voltage systems. So, I'm not calling anything out on that because I'm not looking to see if the telephone or television or the um, internet or any of those guys are bonded. That is really none of my business if it is or isn't. Uh,
Derek, are you
so
going to address the issues with the electric cars, the chargers and all for these things?
yeah, buy a gas vehicle and you don't have to mess with it. So, So somebody asked me the other day about that. And the way I understand it is if it is a plug-in type, which I don't know much about them. If it's a plug-in type, then that's considered a receptacle. So you've got to have GFCI protection. If it is if it's one of the charging systems that's hardwired, then that's not a receptacle. So, and I'm assuming it's going to be in the garage, then it's not going to be required to be GFCI protected. Now, if it's on the exterior of the house, which I haven't seen, and I would assume they make them to be put on they make them or design them where they could be put on the exterior of the house. That would have to be GFCI protected because the exterior, the NEC says outlets shall be GFCI protected. It doesn't say receptacles, it says outlets, excluding lighting fixtures. So if it's on the exterior, then I would assume it has to be GFCI protected, but I haven't researched any of those things yet. Just because I haven't come across enough of them to be concerned about it. The ones I'm seeing are the hardwired ones in the garage. I'm not testing them, I'm disclaiming them. I don't know how many amps are supposed to come out. I don't know. I'm assuming they're going to be 240 at home because it'll charge faster. But they haven't added those to our SOPs, so I would recommend disclaiming them at this point. Something else that has changed for 2023 NEC is the requirement for GFCI protection. And y'all just don't pay attention to the photo on here. I just have it kind of sitting here while I'm rambling on. But 2023 NEC, they changed the wording for GFCIs, or changed the requirements rather for GFCIs in a kitchen. So 2020 and prior to that, you had the requirement for receptacles serving a kitchen counter shall be GFCI protected. The new NEC, 2023 NEC, they said anything in the kitchen. So that includes your range if it's plug-in, because they use the word receptacle, not outlet. If it's a hardwired built-in oven, which you're not going to see that connection anyway, if it's hardwired, it doesn't require a GFCI. If it's a range, say an electric range, 50 amp circuit, 40 amp circuit, and it plugs in, that breaker should be GFCI protected. Same with a gas range. Gas range is required to be GFCI protected. Refrigerator. Disposal and dishwasher already were, because they're within 6 feet of the sink. Dishwasher is specifically called out as needing GFCI protection. The disposer, GFCI protection because it is within 6 feet of the sink, the receptacle. And I've heard this comment a couple of times in the last few weeks. 6 feet of a water source. There is nowhere in this NEC where it says that GFCI protection is required within 6 feet of a water source. It is 6 feet of the edge of a sink, tub, or shower. It's not water source. Now, at some point they may change that, but as of right now, it's edge of sink, tub, or shower. It's not water source. So I've heard that 2 or 3 times, or maybe even more in the last couple of weeks. The other thing that has been a hot topic all of a sudden for some reason, maybe because the NEC just changed again and it comes up about every 3 years. I'm out in the county, or no, let's say I'm in Corpus Christi, and Corpus Christi has adopted the 2017 NEC. Well, Corpus Christi technically is not supposed to do that. The state adopts the NEC, and they typically do it September 1st every 3 years. A city or municipality can amend the NEC, but they cannot, they have to make it more stringent. It has to remain to the same safety standards as what is adopted by the state. In other words, if Corpus Christi wants to require arc fault protection in bathrooms, then by all means, they can adopt that and amend it and require AFCI protection in bathrooms. The NEC does not require that, so the state of Texas doesn't require that. But if a municipality wants to adopt that rule and say, we want arc fault protection in every circuit, they can do it because that is more stringent than the state adopted. There's been 3 or 4 cases over the last 3 weeks on Facebook that I've seen where people are saying, oh, well, they haven't adopted that. We're still on 2017 NEC. The municipalities are not supposed to be doing that. And if you're out in one of those areas, and the builder or whoever has come back and told your buyer, nope, that we're not building to 2023 because this city, Montgomery, hasn't adopted that, then I would simply state that the electrician is bound by their license to install all the electrical components to the 2023 National Electric Code and leave it at that. And then they're going to have to deal with the builder in some way, because what's
Right.
going to happen is when they sell it, if a good inspector goes out there, they're going to write all this stuff up, and then that buyer or that seller may be stuck with that bill to update all of it. So don't let the builder tell you, oh no, we're not on that, because there was an inspector a couple of weeks ago that I think he was convinced that that city didn't have to meet 2023 NEC, even though the state has adopted it. And it's very easy to Google that. It took me like 30 seconds, probably not even that long, to Google that information, and it pops right up. So it's very readily available. The other thing I'm seeing in new construction, the builders trying to save money, is they're putting in a gas range. And so that's only requiring 120 volts. So they're putting a GFCI on that circuit, or they're tying it into the kitchen counter circuit, which is permitted. But they're pre-wiring for an electric range and just putting a blank face over it and putting a regular 40 amp breaker in the panel. Here's my problem with that. I know the NEC says receptacles require GFCI protection. The builder's saving $100 by putting in a regular breaker instead of a GFCI. But next year, when the homeowner wants to put in an electric oven, electric range, and needs 240 volts, they put in that receptacle, that 240 volt receptacle, then they're in violation. They don't know it. They don't know any better. It may get noisy in my house. I think my kids just got home. But I have a problem with that. And maybe the NEC will reword it where they change it to outlets in the kitchen, because that's going to be a problem down the road for those guys or the homeowners when they have a 240 volt range that's not GFCI protected when it's required to. The other thing about the kitchen counter circuits, there are 3 items that are permitted to be on that GFCI circuit. That's a gas range, a refrigerator, and an electric clock. I don't understand why the electric clock was permitted on there. I can't find a definitive answer of why. It makes sense for the electric range. You're probably pulling 1 or 2 amps, if that, for the clock and igniters and stuff. And then refrigerators typically don't pull a whole lot nowadays. So, but anyway, any other questions? That presentation went much faster than it did last
Yeah,
time
question.
because I don't
Sure.
have feedback from anybody. Yeah, go ahead, Rodney.
Yeah, well, I hope I don't open up a bucket of worms with this question. there's something that an electrical requirement, one from 2017 and 1020 from 2020, that essentially I don't see being done on any home. And there was quite a bit of discussion about this back in 2017 and 20. What that is, in 2017, there was a change. I don't have the code reference handy, but where at least one, in my words, I simplify it by using the word dedicated receptacle, was on a 20 amp circuit, was required in the garage. The code doesn't actually say dedicated. It says this circuit shall serve no other outlets other than outside receptacles. Now, I can't recall who all was in on those discussions. I'm thinking maybe you and Clay were. I'm not sure, back in 2017. But I started inspecting for that dedicated, in my words, 20 amp circuit in a garage. And it's essentially never there. All the plugs are on one circuit. So
Right.
the so-called dedicated one isn't there. Now in 2020, they complicated that some by adding some additional verbiage to that same code sentence that also had to comply to another code. And that other code was at least one receptacle per vehicle bay. So the
Yeah.
people I was talking to, whoever that was, said, okay, now we need a quote dedicated 20 amp receptacle per vehicle bay that's on a separate circuit. Each of them's on a separate circuit than the other garage receptacles. And I've especially never seen that one done. What's the status of this? You know what I'm talking about? Nobody's
Yeah,
doing.
but I haven't dug into it enough to know definitively. I know what you're talking about somewhat. And now I will say that I think it was the 2014 code. They had a requirement that something about there had that the garage circuit, there was one circuit that could not go outside of the garage or something like that, or the outside receptacles could no longer be on the garage circuit, but they took that back out after one code cycle. So I don't know what that was about. I have no clue. But I am aware of the one where it says one receptacle per bay, but I don't know that it has to be dedicated. And I can't find anything definitive where it says it has to be in the ceiling. Are they talking about a receptacle for the garage door openers? Are they talking about a receptacle on the wall? I don't know, Rodney. I can't answer it. I know that most new construction now, they're putting 3 or 4 receptacles in a garage.
Yeah, but
Which
it was
one?
this dedicated, in my terms, dedicated 20 amp receptacle that's on a different circuit than the other 20 amp receptacles. As a matter of
Right.
fact, I was going to say one more thing about that.
Yeah, go ahead.
Oh, I even read a commentary, an NEC commentary on that back around 2017. And it said the reason for this is because quite a few homeowners like to use large 120 volt air compressors and things like that. And that was
Oh,
the logic behind requiring this receptacle. But nobody's
gotcha.
doing it.
Right. Yep.
I can send you the code on that or both of them if you'd like. When I write it up, I always tell my clients the builder's not going to do it. I can already tell you that. They're just not going.
Yeah.
I even got in a discussion with the code inspectors for the city of Conroe over it. And they were aware of those code requirements. And there was some kind of random law somewhere that the builders are referring to. And they're like, oh, because of XYZ, we're not required to do that. They were claiming it would make them purchase a different product or some kind of jazz like that. And they had talked the city of Conroe out of enforcing that requirement. The builders
Right.
had.
Gotcha.
So is anybody else writing that up? I don't, maybe I misunderstand the whole thing.
Did they talk them out of it or did they pay their way out of it?
The builders? Yeah, I don't know. But they definitely referred to some law. It must be a state of Texas law that said any code. When I read about the law, I think it had to do with things like siding on a home, certain types of siding you can't use or something like that. or that was the impetus behind the state code. And because of that, like I already said, the city of Conroe says, matter of fact, the city of Conroe code department said their lawyers said because of that state law, they can't enforce that code, right or wrong or whatever.
Open up.
Yeah,
Yeah.
I don't know. I know they changed that code about, I know
Which one?
from every year from 08 to at least 17, they changed something in the garage. And it got kind of frustrating that they changed it so many times, because 08 is when they required everything in the garage to be GFCI protected. And then 11, maybe 2011 is the only one that didn't have any changes, because 14 was the cycle they said that it could not go outside of the garage. So the exterior circuit had to be on its own circuit in a sense. And then they took that back out in 17. And then in either 17 or 20, that's when they added one receptacle per bay. But I never could figure out what that meant. Was it the one in the garage ceiling? Because one in each bay could mean for the garage ceiling for the garage door openers. But I don't know of any requirement for a receptacle in the ceiling in a garage. So I don't know, Rodney. I'll try to, if I get time, I'll try to figure that out and let you know. So, but I know it gets confusing when they keep changing it every code cycle. This we kind of skimmed over a couple of these pictures, but this was talking about contamination. Anytime you see all these nests in there, make a note of that. And this one on the right with the corrosion on the copper, I inspected this house 2 years in a row, almost to the date. I mean, yeah, I inspected it, and then almost a year later to the date, I inspected it again. And I always, on every report, I take a picture of the panel and I put it in my report. Well, even if I came across a panel that there was nothing wrong, I'm still going to have a photo of that panel. And so I got to this house on the second one, and all of the copper was corroded like that. And you can see it's pretty heavy. I mean, it's flaking off of there pretty good. And so I immediately went and looked at that report. While I was still at the house, I went back and looked at that report from the previous year and looked at the photo, and those wires, those copper wires were copper colored. They were pretty, shiny, no green. So I immediately called the realtor, and it was actually the realtor's sister that was selling the house. They had lived there for a year and got transferred or something. And so I started questioning. I said, did they have a pool here? No. I said, and so we finally determined, I kept asking them all kind of questions, and come to find out they had an aerobic septic system, and they were storing their chemicals below that panel. And that took 1 year to get that bad. So anytime you see anybody storing chemicals in a garage, you may want to just kind of inform them, hey, this isn't a good idea. I've seen water heaters completely destroyed. They had an outside mechanical closet at the back of their house, kind of sandwiched in between the garage and the house that they had built and moved the water heaters into. And they were storing their pool chemicals in there. The water heaters were completely destroyed. They weren't leaking yet, but they were literally falling apart. So if you do pool inspections, you might mention to them, hey, get a plastic building and put it out there and store your chemicals in there. Because they will destroy steel or copper rather. They will cause corrosion, something fierce.
All right, Derrick, one thing here, we've got just a few more minutes left to complete our
Yeah.
time tonight. So if anyone has a question, if you'll unmute yourself and ask, we'll get Derrick to go ahead and answer it for you. Other than that, we're going to be going ahead and shutting the webinar down tonight. So I'll give you a few minutes here to answer or ask questions. so we can answer them. We don't want to shortchange you on it. So if you have a question, just unmute yourself or raise your hand or put in the chat box, and I'll get Derrick to look at it and we can answer those for you.
And that photo I pulled up there, I kind of skipped over it earlier, but just because I thought I didn't think I would get through all the slides, because like I said, I wrote this for a 4-hour class. Without interaction in a classroom, it went much quicker. But I mean, obviously there's a receptacle right here and a cord going out of it. I don't remember offhand what that was for. I think they were running Christmas lights and stuff off of it, but that's a violation. That receptacle can't just be hanging out inside the panel. It's got to be in a junction box, so on and so forth. So anyway, yeah, anybody got any questions?
Yes, Derrick, this is James. I have
Yes,
a
sir.
question. I have a question about receptacles in the kitchen, and 2023 seems to address it, but what about a receptacle near a pot filler, since that's become so fashionable to have? And you mentioned that we can only document if it's within the edge of a sink or tub or shower.
Well, if it's near a pot filler, it's on a kitchen counter, right?
Yes, sir.
So it would be required to be GFCI protected because it's in a kitchen.
Okay. Okay.
Yeah. That 6-foot rule, where I'm seeing it come into play is outside of a bathroom. Say it's a Jack and Jill bathroom or a Hollywood bathroom, whatever you want to call it. There's a receptacle in the bedroom, which is 5 feet from the sink, measured through the door. Not through the wall, down the wall, through the door, and up to the sink within 6 feet. That's where I'm finding them, or I find them in a hallway just outside of a bathroom if it's within 6 feet of the sink. The other place that I found them was in the high-end home. Sometimes you'll see a little wet bar sink in a closet for making coffee and such. And that's where I'm finding that 6-foot rule. But that 6-foot rule is I kind of look at it as in layers. That's the last layer. If it doesn't fit any one of the other categories, if it's not in a bathroom, if it's not in the kitchen, if it's not exterior, if it's not in the garage, and then it's within 6 foot of a sink, like in a hallway or a closet, then it's got to be GFCI protected, because GFCI protection is not specifically called out for in a closet or in a hallway. That's where that 6-foot rule comes in. That 6-foot rule is separate from all those other requirements. So don't get confused with that. Everything in the kitchen, no matter, it can be 12 feet away from the edge of the sink, still has to be GFCI protected. And the other thing that comes into play now is, where does the kitchen end? Some of these houses, most of them, it's pretty cut and dry. Countertop is the end of it. That's the end of the kitchen. But there have been a couple of times where there's a strange design where there's the kitchen pantry and there's a wall receptacle between the kitchen pantry and the end of the countertop. Is that still in the kitchen? I think so. So if it is, it's got to be on the GFCI. Now, the other thing to think about, and this gets kind of deep into it, if that receptacle is in the kitchen, it's got to be GFCI protected, but it can't be on that. Can it be on that GFCI circuit that serves the countertops? Because that is not a countertop receptacle, and a countertop receptacle would not be more than 12 inches below the countertop. So I don't know. It gets kind of, it depends on how deep into the code you want to get. And the other thing I've seen on this new code about no receptacles on the island, I was at one last week where they had a receptacle on the back side of the island, and they were calling it the receptacle for the living room, which was big. Hang on, buddy. Okay, good job. He's potty training. So, God, I lost my train of thought with that. They were calling that a living room receptacle, and it was on the dividing wall between the kitchen and the living room. But it was on the circuit with the kitchen counter receptacle, so you can't do that. So Is it gonna be a big deal in the end? Probably not, but it's just things like that that I question. And I'll let the buyer know on new construction. I mean, you go inspect a house from 1980, you're gonna, if you went that deep into code, you're gonna be writing for days and days and days. So you gotta pick your battles.
Thank
But,
you back, Derek. Anybody else have a question you need to ask Derek before we get off this thing?
Yeah, I got one. How about a butler's pantry? I always look for GFCI there, and they're usually present.
I think, I would have to verify this, Rodney, but I think they added something where it says food prep areas.
Yeah, I know what you're talking about.
But
Okay,
I will say I went to look for that here recently and I couldn't find it, but I know I've read that somewhere.
an area used for food preparation,
Yeah,
something like that. Yeah.
Yep.
So you would say yes on the butler's pantry.
I would. And again, I think in a sense you could consider that part of the kitchen, depending on the design.
I tell you what, I have also considered part of the kitchen. I've seen some new homes that have a pretty open kitchen, and then maybe say at the right end of the kitchen counter that's along the wall, maybe a slight space, and then an additional at the same height, long, essentially kitchen counter, but it's in the formal dining room area. It's all
Yeah.
an open concept. And
Yeah.
then they have receptacles all along the backsplash for that essentially extra long kitchen counter in the dining room. In my
Right.
opinion, that's the area used for food preparation.
I
But
agree.
that's just
And that's,
me.
again, one of those things, where does the kitchen end?
Yeah.
So you gotta kind of make that determination. So anyway,
All right, for maybe just one more question, if someone has one you haven't asked, go ahead and ask for us.
I had a quick question. I was in a home where I tested the GFCIs along the backsplash and the oven and microwave went off. So they were sharing a circuit and I was pretty sure that was not allowed, but I was wondering if you could speak to that.
the oven is permitted to be on that kitchen counter small appliance circuit. The microwave is not.
Thanks.
Oven, refrigerator, and electric clock. And if anybody can tell me why an electric clock was thrown in there, I'll send you a 6-pack of beer. Because I can't find any reasoning for electric clock. The range, I can see the reasoning because it's there. And the refrigerator reasoning, it's there, but electric clock, I don't understand. So
Good
anyway,
Good questions. All right, folks, we're going to go ahead and close it out for the night. I want to say, Derek, thank you so much for your willingness to come on and present this thing and for all the knowledge and experience you've shared with us tonight.
Sure.
We all will give you a thumbs up, I'm sure. And I'll let you guys go. Brenda's going to be doing the continued ed hours for you. She'll get those turned into Trek for you. So next few days, you should be able to see that on your Trek website under your profile. And if you want credit for InterNACHI's CPI for your CPI status, you certainly can go in and post this 2 hours into that so you can obtain those hours also. So we'll end with that, but thanks to everybody for attending. Thanks for your your questions that you've asked. And we hope to see you again sometime on another one of our webinars. So take care.
All right.
We'll see you guys later.
All right. Thank y'all.